Hey everybody, this is Larry. This is day 12 of the Leetcode Daily Challenge. I'm guessing we're gonna have a linked list problem. Let's see what's the situation. A copy list with random pointer. A linked list of length n is given such that each node contains an additional random pointer which can point to any node in the list. Construct a deep copy of the list. Okay, what does that even mean? A linked list of length n such that you contain. Okay, so basically there's a regular pointer and a random pointer, right? Okay, none of the point in the new list should point to nodes in the original list. Okay, that makes sense. This doesn't, I don't think that the random thing changes anything. Well, I mean, I guess the normal way that you would do it is you construct it one at a time, and then you make sure that everything is ready when you do it. Do we want to do it in constant space? I guess so. Okay. I think the tricky thing about the random index is that you might have a pointer to a random thing before it is ready. So I mean, I think we can do it in two paths very trivially. So let's do that. You can also kind of do it like recursively, almost like can you do it recursively? Yeah, I guess you could do it recursively in that even because if there's a cycle, it just gets the pointer, almost kind of like what you might call it, like a dependency or topological sort, I guess is what I was trying to think of, like the dependency graph type thing. So I don't think it's that bad. Are the numbers and the values unique? I guess that's the thing that I want to see, and it does not appear to be. Let's see. I guess it doesn't appear to be. So that part, it's a little bit tricky. Maybe if it's not the, oh yeah, and here in example 3 you can see that it is not unique. So that part could be a little bit tricky. Because I mean, I think you could do it. It's just a little bit more annoying in that I mean, it's just more bookkeeping, right? Just more keeping track and stuff like that. And you can definitely do it in constant extra space per node, which means linear extra space. So yeah, okay. But that you need linear space anyway. Okay, I think we're okay here. I mean, it just makes things easier, but it doesn't change anything. So yeah, okay. So the first thing I would do is I think what I'm thinking right now is just thinking about how to explain it, to be honest. But I don't think this is that bad. It's just about lookup tables and stuff like that. So let's get started. So we have a lookup table. We have I always like to have a sentinel called new head. Is equal to oh, I guess that makes sense. I was gonna say why it's not a regular list node, but I guess that's a random node. And then new head dot next is equal to head, and then now yeah, then current is equal to new head, and then well, maybe that's not let's see. Okay, fine, let's do it this way. And then we have answer head is equal to node of, well, we put a sentinel here as well. And then now we go with while current is not none. No, this is just a regular deep copy. We ignore the random thing for now, and we can think about how to incorporate it later. Okay, answer current maybe. It's just a lot of pointers, but it's not that big of a deal. Yeah. Okay, so then I'm just double checking that they're aligned because basically you're just doing one at a time, right? So then now answer current is go answer current dot next. That's how we increment per se. But before that, answer current dot next is equal to new node of current dot next dot right, kind of. Let's see, because we have to. Okay, fine, right? So we can do. Let's put in a function, I guess. Deep copy. I think deep copy is actually a function name, though. So maybe maybe I'll just call it DC for now. I don't remember if that's a thing in Python. I think it's deep copy though. I think that's the name of the library. But yeah, okay, so we have node. If node is none, return none. Otherwise, return. Okay, so this is deep copy without the random edge, you say. So then return node.value, and that's it. Oops, I've been hitting that lock key button a lot. What's my password? Okay. Okay. So then now, yeah. So we create a new node and then we set this node. So here we should be, in theory, done with without the randomness, right? So that's one thing that I want to check first, is that without the random edge, is it good, right? And it looks like it should be good. It looks like 7, 13, 11, 10, 1. That's what you have here. And we have everything looks the same. We just have to. I assume that this is the random node stringification or visualization. So then now we just have to keep track. Okay, so that for each node. Yeah, I mean we could do it in two. I think the concept of a pass is weird anyway, but yeah, I mean I think we can do it in 2 pass. We can do 3 pass. That's slightly easier. So let's do the random part separately. And yeah, we just have to look up. Let's move the lookup closer to its execution. Maybe even have a helper, but that's fine. So current is equal to new head, and then while current is not none, and again you could combine it here if you really want to, but you want to do it for a little bit. Yeah, current is equal to okay. Actually, what I want is. Sorry, there's like a car alarm that's going on outside and it's kind of distracting me. Don't know if you could hear. Hopefully not, you cannot hear, but for me, it's a little bit distracting. Okay, so then now current is equal current.next and ends current is equal to ends current.next. And what we want to do, of course, is construct basically a mapping between the lookup, the previous node and the next node, and then now we can do it again. Now that we have the mapping, can do the final pass. Oops. Which is that we do lookup of lookup of I misspelled current. The lookup of current dot random, is it edge? And assuming that this is not none, right? So if current dot random is not none, then lookup of random is going to contain the node in the second list. So that means that answer dot current dot random is equal to this, else answer current dot random is equal to none, and of course we propagate. This is very long, but hopefully it is correct. Oh, answer current can be. Did I mess something up? Oh, I just typoed it again. Wow, I typoed it twice. Okay. But yeah, another way you can do it, I did it iteratively, but you could probably do it, like I said, recursively with sort of like dependency type figure. Maybe that's the easier way to do it. I don't know. But yeah, this is going to be linear time. We have 3 while loops. Maybe I did want to try to do it a little bit differently. Yeah, linear extra space, but linear space for the return type anyway. Cool. That's all I have, really. Let's see, how did I do it the other day? Okay, I actually did it the same way, pretty much. Huh, okay. So except for I combined them like I said. Okay, I was curious whether I did it recursively. Yeah, that's all I have for this one. Let me know what you think. Stay good, stay healthy, take good mental health. Take care, and I'll see you later. Bye bye.